The beam that's shown here is pinned at A, roller support at B, clockwise couple there at C, and then a downward concentrated force P there at D. We want to know the shear force and bending moment diagrams for this beam. We'll begin by drawing a free body diagram of the entire beam, with our goal here to find the reactions. I've got AY and BY, a couple at C, there at MC, and the concentrated load P acting there at D. I'm going to write down an equilibrium equation of summing moments about A. I got minus MC minus P times 2D. BY, that has a moment arm of 3D. And for equilibrium, that is 0. So BY in this case is 50. Some forces in Y direction. Get AY plus BY minus P for equilibrium. I find that AY is equal to 10. So beneath here, what I'm going to do is break down the shear force and bending moment components. There is a concentrated load there at 2D, so that's at 2. So I need to take shear force all the way to a point immediately to the left of there. And since AY is positive 10, that becomes a positive 10 because keep in mind a positive shear force on the left face is up. Immediately to the right of there, that's at 2 plus, that's what it is at 2 minus. And since P is downward, when we make that a minus sign, that gives us a minus 50. The shear force at 3, that's equal to the shear force at 2. And so that's a minus 50. And that jives with what we had before. We said that BY was 50 upward. On the right face, up is negative, so therefore that sign agrees. The shear force diagram then, it's going to be a constant all the way over to D with a magnitude of 10. There's a jump downward to minus 50. That's minus 50 for the rest of the way to the right. The bending moment, immediately to the left of C, that's going to be what it is on the left end, and that's equal, and then add on the area under that curve, so that's 10 over a length of 1, so this becomes 10. The bending moment at 1 plus is what it is at 1 minus. The bending moment here, MC, is clockwise, and a clockwise couple makes a jump upward, so that's a plus MC. That becomes a 40. The bending moment at 2 is bending moment at 1 plus, and then I add on to that the area under this curve, which is again 10 over a length of 1. So the bending moment there is equal to 50. And finally, at the right end, x equal to 3, that's equal to x equal to 2. And then the area under this is a minus 50 times 1. And the good news is it is a 0, as it should be. there's a roller support there at B, so there should be no bending moment acting on the beam at that point. So our bending moment diagram, it starts out at a 0. It goes up to 10. Like that. There's a jump up to 40. Like that. And then it goes up again at a linear rate up to 50. And it goes down at a linear rate to a 0 there on the right end. So again, what we did, we drew a free body diagram of the entire beam to find the reactions at A and B. We really only needed A, but by finding B, that provides us with a check. And then from that, we were able to march from left to right on shear force. And then the bending moment then is the area under the shear force in addition to that jump upward there at C. That produces the shear force and bending moment diagrams that are shown there in the figure.